Hi Khan Academy, my name is Sankalp Agarwal. I also go by Sunny, and this is a video explaining my submission for the language agnostic project portion of the interview process. So first I'll start off by going through a little bit of my code and then give a demo of the website that I created. So I realized that I actually chose a language agnostic project, but I ended up writing it in JavaScript anyways, so go figure. But anyways, the reason I did that was because to create the visualization portion of the project, I wanted to use D3 because that's what I've been comfortable with using lately. And I've been trying to learn D3, so I ended up using JavaScript anyways. So basic HTML layout, nothing fancy here. Same thing with CSS, just a few libraries I use. Same with HTML, just some stuff to make my buttons look nicer and Bootstrap and whatnot. The main bulk of what we want to look at is here in the main.js. So essentially what I do is I input a JSON file that contains all the users. So essentially what we see here is it's a dictionary. It's a JSON file that has all the user IDs along with all the students that each user has. And after importing that, what it does is I created a user object, which I defined down here, and created user objects for each of the data points in my jQuery. And then with a few more functions, after creating all the users, I assigned all the users student array to contain other users to create these connections. And I also set the coaches by reversing that. Then here I set them into groups, which allows you to see all the isolated parts of the network. And finally, this is all some D3 visualization stuff that I use to create the visualization. And finally, this is my infect function, which you can input a user to infect, and it does so. My limited infect, which allows you to choose a number of users you want to infect or a proportion of the total number of users, and it will try its best to infect that many users using an implementation of the knapsack problem I've used with like dynamic programming and memorization, so it goes much faster and doesn't crash my computer every time I try to run it. And finally, yeah, that's about it. So I'll go ahead and open up the website. I'll just open it up in a Python server. And let's open up Chrome. Localhost 8000. Okay, so this is the website that I've created. So here's the D3 visualization, and basically what I can do from here is choose any user to infect. So each of these separate portions of the graph are pretty much isolated portions of the network, so that way if I infect a user in this portion, it has to have no effect on anyone not connected to these by these links. So for example, now what I can do with the visualization is I made it so you can click on any user and you can see how the infection spreads. So for example, if I click on user ID number 10, it turns green, and then turns 9 and 8 green, then it spreads to the rest of the network and goes step by step showing how the infection spread. And as we can see here, there are now a total of 7 users that are infected. If you do want to see which ones are infected, you can click the show button and we'll give you a little pop-up telling you which ones are infected. Now you can reset everything, and you can also do the same thing from the text box. So if you can choose the user you want to start infecting, so let's say number 15 infect starts here, spread to these, so on and so forth. Okay, the next major portion is the choose number of users to infect. So this is where the knapsack problem comes in. So let's say I want to infect, let's say 8 users. What I can do here is click infect. Using the knapsack problem, it finds the most efficient way to infect exactly 8 users, which happens to be this group of 6 and this group of 2. Now, what I also added was the functionality to do exact. So for example, let's reset this, and let's say we wanted to infect 30 users, and there's clearly not 30 users in this graph. And click infect, it does the closest possible thing, which is infect everyone. However, if I wanted to do it exact, I can do 30, in fact, and it says, whoops, there's no way to do that because there's no possible way to infect the said number of users without breaking some of the rules that were defined in the heuristics. So finally, the data I used as example data, this one is just pretty much what I personally decided to use. I just made a few different things. The reason I chose these was I thought it gave a good example of different kinds of structures that Khan Academy may have. For example, this one is a classroom with one teacher and many students. So this one teacher teaches 6 students. This one is a example of like a classroom with multiple teachers, or one class that has different classes in like the same school, which all the teachers use Khan Academy. So this one has these 4 students all share these 2 teachers. Finally, this one is an example of a student teacher. So in this example, 8 teaches all of these students, but it also teaches 9, and 9 also teaches all the rest of the students. So this is an example of a student teacher to show that the network still works there, so it still spreads like normally. This is an example of one-on-one coaching where 21 teaches 22. There's not much complicated about that. And obviously, Khan Academy has many independent users who don't really use this coaches feature. Maybe they're just using it for their own studying purposes. So I added a few of those. So yeah, that's pretty much my code and a demo. And I look forward in doing the online call interview. Thank you.